Hey everybody. Today's pencast is, I hope, going to be a short one. That's my plan, because what I want to do is show you, let's recap first of all, before I show you what I'm going to do. Let me show you what we've done. We've factored quadratic trinomials in the form of, like this, for example, x squared plus 8x, and let's say plus 15. Real simple. And what every single one that we've done so far has had in common, besides it's been, well, they haven't all been trinomials. Some of them have been binomials. The leading coefficient, the one that was attached to the quadratic term or the square term, has always been 1. There's been no difference in that. And because of that, we've used what I call a sum product method. For factoring, we ask ourselves what two numbers will give me the sum of a positive 8 and the product of a 15. And we've put those two numbers into a binomial. For example, the product would be 5 and 3. We've done this before. This should be pretty simple. 5 times 3 is 15. 5 plus 3 is 8. They would both be positive, and our x's would go here because it's the x times the x, whether you use the FOIL method or the box method, that gives us the 1x squared, because 1x times 1x is 1x squared. What happens when you need a number other than 1 as a coefficient for a quadratic? Well, these two numbers here and here wouldn't be able to just be x's, would they? Because say I said it was a 4x squared. Well, now you've got a couple options on the forward variables. It could be a 2x times 2x is 4x squared. 1x times 4x is 4x squared. So now we have another changing option that is going to affect these guys too, the numbers that we have. Oh my goodness, it is arrow crazy. What I'm trying to say, we need another method. Sum product method isn't going to account for the front numbers. It's only the back numbers. We add these, the sum products here, and then the fronts take care of themselves. So let me show you an example. Or I'm going to show you a couple examples. But I'm going to clear, hopefully, I can clear this without clearing the other. I can. Okay. So I took this off of the CUDA software site. It's problem 1 through 4, and you're going to notice that the answers are in red. I've left the answers because I want you to see what we're trying to do here. The question was this: factor 3p squared minus 2p minus 5. The answer: the quantity of 3p minus 5 times p plus 1. If you FOILed or box method that, you will get the product that they gave us of 3p squared minus 2p minus 5. The question is, how the heck did they do it? They didn't use some product. Well, they kind of did in a sense, right? So let's do something here. Let's pretend like, I need a little thicker there, don't I? It'll take me an hour to do that. Let's just pretend we don't know that. In fact, I've already forgotten it. I've got a very short attention. So let me pick a color. What color makes me feel happy? Purple. Shout out to my purples. Woohoo! Okay. Sorry, pinks, reds, blues, I love you too. There's 4 problems. 4 colors. All right. Here's what I want you to do. What do you get when you multiply 3 times a negative 5? The first and the last. You get negative 15. That's a little too thick. I'm going to bring that down a little bit. Got a little carried away. Okay. What do you get when you multiply the first and the last? You get 3 times negative 5. You get negative 15. That's better. Can you break down the number 15 into 2 factors that would add or subtract to give you the negative 2? So it's kind of like sum product, but with a tiny little twist. You have to get your product number, has to be the back number times the front number, because now we have a front number. We actually always did this, guys. It was just always a 1. So the 1 times the back number, which we used to call our product number, was always the product number itself. So now we have to times whatever number's there, in this case a 3, times the back number, a -5. That gives us the product. We're still trying to get the sum of that center or the linear term, which is a -2. So think of sum product now. Here it is. It's a -2, -15. It's even in sum product order. So what two numbers will combine to give you the product of a -15 and the sum of a -2? You already know it. It's going to be a 3 and a 5. Just like the other example I think I did, but in this case I think we're going to have to subtract, right? It would be a negative and a positive. I do believe it would. All right, so now here's what we're supposed to do, and I just want you to know I'm as new to this technique. This is a new technique straight from the high school teachers. Came to me and said, we've got an awesome way to do this that we think your students are going to really like too. And the minute I heard it, OMG, I loved it. I loved it. It was love at first sight, guys. And I said, totally. Here's the problem. I've never really done it live, so I'm going to try to remember what you do. Okay, here's what you do. What we do is we take the +3 and the -5, just like we used to, which is the only problem the only thing that really worries me is it's right now looks exactly like sum and product when we know it really can't be. Okay, so I copied the sum and the product, put them right where they always are. I'm not allowed to do that. That's not the answer, because what would P times P be? P times P would be P squared. What is it supposed to be? It's supposed to be 3P squared. So here's the trick, and this is a total trick, guys. Take the front coefficient, your leading coefficient, which is a 3, and put it under those numbers. So once you do the sum product, you look at the front number. If it had been a 1, this wouldn't be changing anything, right? Because when you divide by 1, you'd be done. And that's why with the sum product method, you're done right now, because these would be 1s, but they're not. They're 3s. And now what we need to do is, well, this simplifies, right? 3 divided by 3 is 1. So this quantity is P plus 1. And here's the little switcheroo. Instead of writing P minus 5 over 3, we're going to really technically multiply both of these terms by 3. That'll cancel that 3 out, and it's going to put this 3 in front. Different color, different color, different color, different color, different color. The 3 goes in front instead of under the 5. It goes in front of the P. So let me finish this in a color like so. Okay, erase, because I wouldn't want to do this without knowing if that was the actual answer. 3P minus 5P plus 1. That's the right answer. Now, don't even, I know your head's spinning. I feel it. My head's even spinning and I know what I'm doing. Don't freak out. I want to show you the next one. The next one will go a little bit easier because you've got a little bit of a feeling as to how we're doing this. All right. It's a new method, and I know it's a little bit confusing, but it is, let me tell you, for those, shout out to all of you who did it the guess and check method, where you just kept making up options and seeing if they worked. It's just so much nicer than the guess and check. All right, here's what I'm going to do. I'm going to hide that. I suggest doing this, at home. Just hide the answer and do a little reveal at the end. All right, I'm feeling good. This is going to be a shout out to my blues. I'm going to so be in trouble if I can't do all of my groups here. All right, do you remember the first thing we have to do? You have to times the 2 to the, and I've got a thick, okay, sorry to growl. The first times the last gives us our new product number. That's a -9, and 9 is 18. So my sum is 3. My product is a -18. What two numbers will give me the sum of 3 and the product of a -18? Should we try 6 and 3? That's what's coming to my mind. So here we go. We do it like we always did. An in here, an in here, a 6, a 3, your signs, your signs. All right, if this is not easy for you, stop right now, go back, and do more practice on just factoring using sum product. You only do this level if you're finding the sum product method boring because it's too easy. Then you move here. Do not continue this video if you do not know what I just did with the 6 and the -3. So that would be sum product, but we can't. Can't use sum product because of this 2. So we take that 2, what do? Put it under these 2. Now, simplify if you can get an integer, a number that is not a fraction. So here I can, 6 divided by 2 is 3, right? So my first binomial is n plus 3. Look at the other binomial. Well, I can't have that fraction there, so I do that little wiggity wig. I don't know what else to call it. It's like a little zoobity zoob thing. I multiply both sides by this, not sides, they're not sides. I multiply this by 2 and this by 2. Those 2's cancel out, and we wind up with 2n minus 3. And then look, reveal, n minus 3, n plus 3, 2n minus 3. It worked. Okay, digest that for a minute. Rewind, play it back, but I'm going to go on. Okay, I did my purples. I did my blues. I am moving on to 50-50 chance. What is it going to be? I'm feeling pretty in pink. Yes, I am. Okay, pinks, here we go. I don't want to know what the answer is. I think I'm going to keep working up here because it's a little bit easier for me. So let's get my product number. It's a 3 and a 4. Okay, so my new product is going to be 12. So my sum product is -8, 12. All right, so what's -8, 12 going to be? Think about it. Got it? I think I have it, 6, 2. We'll find out. So we do this, we do this, we do 6, we do 2. So how do I get a -8 with a 6 and a 2? They both have to be negative. So that means my product better be positive, and it was. It was a positive 12. Okay, now what's the thing we have to remember to do? Divide these back ones by 3. Simplify if we can, right there. And then bring the other one. You can't think of it as just doing that, bringing that one to the front. So now that will become a 3. So then the final answer, n minus 2, 3n minus 2. And we'll reveal 3n minus 2, n minus 2. Oh my gosh, I love this method. I so love this method. You know what you need to do right now? You need to go find your parents. You need to show any of them that remember how they learned how to do this. You need to go show them. And you know what? I'm talking to somebody. I'm doing a shout out to somebody. Somebody right now. She's not a loser. She is a winner. She's not a loser. She's a winner. She's my Jaqueline. I'm saying it. Jaqueline, go get your mother right now. Show her this method. You are a winner, girlfriend. You're a winner. I'm just here to say it. And you know what? Your mother's a winner too. Your whole family's a winner. In fact, all of my reds, because it's red time, are winners. Not just my reds, my blues, my purples, my pinks. Anybody on the World Wide Web, they have no idea what I'm talking about. Isn't that what's wonderful about the internet? Okay, I got it, guys. It's you know, there's a lot to do here with all these colors and, ooh, reds. I gave you some big numbers here, 5 and 12. Hope you've been studying. Yes, I hear you. It's 60. I agree. My new product number is a 60. So how do we do this? Same way we always did, right? I know you're going to pause me if you want to do it yourself because I am just on a roll. I'm in a hurry. I still got to get my makeup on and get dressed for work. So here, there's the ends. Oh gosh, 60. Ways to put factors of 60 together to get 19. Well, you know, I'm going to throw some out. I think I know what it is, but I just want to show you how do you work through something like this. If I've got 60, how many ways can I break it up? Well, 1 in 60. Yeah, that's not going to give you 19. 6 and 10, right? And that'll give you, nope, 16 and 4. That's no good. R8, trying to think of another one that I know is not going to, well, 12 and 5, right? We just put 12 and 5 together. That could give me 17. That's really close. That's annoying. Too close. The one I'm thinking it is I think of 60. I do think of 15. You may not. But I think actually when I think of 60, I think of 30 and 2. And that's not going to work. But when I think of 30, I think of 15. And so that's where I get the 15 and 4. I know it's hard to be inside my head, but there's your 19, 15 and 4. So this one's 15, right? This one's 4. They're both positive. Isn't that nice? Divide everybody by, not everybody, but divide by 5. Simplify if you can to get an integer. There's my 3. So this one is n plus 3. And then take this guy, put it in the front, 5n plus 4. La, the angels sing. Maybe the angels shouldn't sing till we see the answer. Okay, 5n plus 4, n plus 3. We got, okay, now the angels sing. This, now anybody who did do what I say, you grabbed your parents, you showed them, they're sitting there, they are in shock. Look at them. Look at their faces. They're in shock. And you know why they're in shock? Because they didn't learn this way. They learned the way I did. Old school, shout out, whoop, whoop. And the old school way was, let's just call it annoying. It was awful. So now you don't have to do that. You've got a method, a specific way to solve what used to be a really annoying process of guessing and checking and guessing and checking. Now you have a mission. So now all you got to do is practice. Go to CUDA. I saved you plenty of practice. There's practice of trinomial factoring all over. All you got to do is find it and find an answer key, because you got to check yourself. And you could check yourself using box method or FOIL, but that's just like a whole nother process. Too much work. That's all I got to say about that, except you know what? I'll see you on the flip side.